Hey guys, all right, this video is going to be on percents of increase and decrease. This is still part of Unit 6 and it is Unit 6.4. So go ahead and make sure you write 6.4 up there at the top. That will help you keep track of this. Make sure your name and your period is on it as well so that if it gets lost, I know who to give it back to. So our learning intentions here are going to be able to find percent of changes in quantity. You'll know you're successful with this when you can explain the meaning of percent of change, when you can find the percent of increase or decrease in a quantity, and when you can find the percent of error of a quantity. So on this page, you're going to see 4 different key terms. Each one has a different formula for you. So the percent of change is the first one, and that's the percent that a quantity changes from the original amount. So the formula for that is percent of change equals the amount of change over the original amount. And that's where percent of increase or decrease comes in, because we need to figure out what is that amount of change. So we have to find out, is it an increase or a decrease, and then we'll follow that formula. So the percent of change when the original amount increases is the percent of increase. Okay, so how you find that is you're going to take that new amount, since it's an increase, so that's the larger number, and you're going to subtract it by the original amount. And then that's going to be all over the original amount. So we're going to take this number and divide it by the bottom number. Okay, so in the percent of decrease, that is the percent of change when the original amount decreases. So again, we're going to take the larger number first. So we're going to take the original amount because this is a decrease, right? Decrease means it gets smaller. So we're going to take the original amount, subtract that from the new amount, and then divide all of that by the original amount. And then our last one is percent error. Now, percent error means the percent that an estimated quantity differs from the actual amount. So estimated quantity differs from the actual amount. So what that means is, say you buy an 8-ounce can of lemonade. It says it's 8 ounces, and you decide to go home and pour it out and measure how much is actually in it. And when you do that, there's actually only 7 ounces. So to find the percent error, you would take the amount of the error. So if it was supposed to be 8 ounces and it was only had 7, so you do 8 minus 7. So you'd have 1 ounce as the error, and then you'd put it over the actual amount, which is the amount it was supposed to be. So 1/8, and then you'd figure out what percentage 1/8 would be, and that's the percent error that they had when they made that item. Okay, so these formulas are going to be important as we go through this section, so make sure that you're referencing the formulas on the front of this page. And we'll come back to it a couple times too as we do the guided practice. So let's look at the back side. So here's our guided practice. And what we're going to do here, first we're going to find the percent of change, round to the nearest tenth of a percent if necessary. So the first one says 10 inches to 25 inches. Well, 10 inches to 25 inches tells me that we're going from the original amount to a larger amount, which means we're increasing, right? So if I was to go back here and look at my key terms, the percent of increase is the new amount minus the original amount all over the original amount, okay? So let's see. So my new amount was 25 inches minus my original amount all over my original amount. So 25 minus 10 is 15. 15 over 10, which would be 1.5, which then, as I know about learning percentages, changing decimals to percents, I multiply this by 100, which means I move my decimal place 2 places to the right to get the percentage. So when I do that, that's going to become 150%. So the percent of change, or the percent of increase from 10 inches to 25 inches, is 150%. So now this next one is 57 people to 65 people. So if I started with 57 and now I have 65, that means I've increased, right? So I'm going to keep this same formula. I'm going to say 65 people to 57 people, all over 57 people. So 65 minus 57 is 8. 8 over 57 is going to bring us to 0.14 or 14 hundredths. And then I know by what we've learned about percentages that I'm going to multiply this by 100. That will get me 14%. So it is a 14% increase when you go from 57 people to 65 people. Now our next one says 75 people to 25 people. Well, clearly that is a decrease, right? And quite substantial of a decrease. So let's go back and look at the formula again. So the formula for decrease is the original amount minus the new amount, all over the original amount. So basically we'd make sure we take the larger number, whether it's the increase or the decrease, we're going to take the larger of the numbers, and that's going to be the first number that we put in our formula. So 75 people minus 25 people over 75. 75 minus 25 is 50. 50 over 75. So if I threw this into a calculator or I did some long division, that would get me 66 hundredths, which I need to put this into a percent. So move my decimal 2 places to the right. 66% would be my answer. So it is a 66% decrease from when we go from 75 people to 25 people. So our last one is 72 paper clips to 63 paper clips. Again, it's a decrease. And regardless of decrease or increase, we're going to take the larger number first, right? So we're going to say 72 minus 63 all over 72. 72 minus 63 is 9. 9 divided by 72 gets us 0.125 or 125 thousandths. Multiply that by 100, move over our decimal place 2 places to the right, we have 12.5%. So it is a 12.5% decrease. All right, so our last problem here is going to be on percent error. And it tells us you fill the bag with about 16 ounces of homemade dog treats. The acceptable percent error when filling a bag is 5%. So tell whether each bag is acceptable. Well, first we need to use the percent error formula to figure out what is the actual percent error. And then we can tell whether it's acceptable or not. So a couple things that I want to give you for information is the bag A is actually filled with 15 ounces and bag B was filled with 16.5 ounces. So the amount of error is 16 minus 15. So it was 1 ounce. The error was 1 ounce. So let's look at that formula again. Percent error formula. We take the amount of the error over the actual amount. And when I say actual amount, that means the amount that it was supposed to be. Okay? So we're going to take our amount of error, which was our 1 ounce, because we took 16 ounces minus 15 ounces. So what it was supposed to be, what it ended up being, and then we get 1 ounce. And then we're going to put that all over the amount it was supposed to be. So 1 over 16 divides out into 0.06. We'll just stop right there. So 62 thousandths. And then I'm going to change this into a percentage. So move my decimal 2 places to the right, 6.2%. Now this one, the amount of error, so I actually gave them more dog treats this time, right? So it was only supposed to be 16, but I gave them 16.5. So 16.5 minus 16, there was amount error of 5 ounces, and it was supposed to have 16 ounces in it. So 0.5 divided by 16, you can use a calculator here, would be, it goes on for a little bit, but we're just going to go a couple decimal places. We'll say 0.31 or 31 thousandths. And so then let's make this a percentage, 3.1%. So now the question says, tell whether each bag is acceptable. Well, the acceptable percent error when filling the bag was 5%. So let's look. Bag A, it ended up being 6.2%. So that is more than that 5%. So no, it is not acceptable. So we're going to say no, not acceptable. And then we have bag B. It was supposed to be 16 ounces, ended up being 16 and a half ounces, and the percent error was 3.1%. Well, 3.1% is less than 5%. So yes, this is acceptable. Yes, acceptable. Okay, so that's some guided practice for you. You have a couple problems to try on your own. And these are just going to be on identifying increase and decrease. And there is not a percent error problem for you to do on this. You try it. There is an additional step though. I want you to tell me as you're working through this problem, you're going to write out, is it an increase or a decrease? Whatever it is, you're going to make sure as you're doing the formula, you write somewhere on here, increase or decrease, because I want you to be able to identify whether we're increasing or decreasing because it does change the formula. So make sure you identify it first, then you can solve it. If you need to, you can round to the nearest 1/10 of a percent. It really is your preference if you would like to do that. All right, guys, have a great day.